Okay, so let's get down to how we actually measure resistance with a multimeter. So again, as we had before, our black one is in the common connector on the multimeter. Our red one is on that omega sign, or ohms, on the multimeter, which is normally shared with your voltage measurement. And then we just flick our selector through to the ohm, or that omega sign again. And the multimeter is set up to auto range, okay, and by default you'll see it sits here in this overload mode because basically it's got nothing to measure. So let's get to our switch. So if we have it in the up position like we did before, and we put our two probes between those 2 points, you can see we've got the overload on the screen there because it hasn't got any reading. There's no continuity between those 2 points. I should go to these two because actually, depending on where the switch is, it could be either of those. And if I switch it this way, I think we'll note, yeah, there's no continuity there. We go here, and there we go. We've got that 0.2, 0.4 now. So remember, basically, as I said, there was that resistance potentially in the lead. So in essence, we've got close to zero resistance going through here. Okay, I say that, and as I play around, you can see we're getting just above 1 ohm. So this is also where you can check continuity if you don't have a continuity buzzer, is to put it to the resistance setting on your multimeter and check resistance. And you kind of want obviously as close to zero as possible to show that you've got good continuity. Right, so now let's get to the resistor. This is going to be difficult. I might have to use press stick, but so here we have our resistor. And what I'm going to do first is I'm going to take the tester. In fact, I'm going to get some press stick because that's going to be just a little bit challenging without moving around. If I take a measurement on this side of that resistor, on that wire, we can see we've got basically almost 0 ohms. Now if I go to this other side, across the resistor, it is 1 kilo ohm, so 1.000 kilo ohm. So that is 1,000 ohms across that resistor. Now let's get another resistor. And again, you'll note this is out of circuit, because if you're trying to find resistance in a circuit, you're basically measuring the resistance between all the components between your two probes. So if you want to measure something specifically, sometimes you have to be very careful. You have to take it out of a circuit to actually get a good clean reading, or else you could have other components within a circuit which could upset your reading. But here we go. We put the two probes on either side of the resistor. I just have to push down to make sure we get a good clean, and there we go, 390.3 ohm. Now again, remember, so this is a 390 ohm resistor, but that 0.2, 0.3 at the end is that potentially the resistance which is sitting in your leads. So I say, if it's something really critical you're measuring, just remember you have to account for even the resistance in your leads itself. And literally, it's as straightforward as that. Just placing them on either side and picking up the reading.
This is a resistor, and what we're going to do is bend it and put it into 2 holes. When we come out on the inside, we want to bend the sides out so it doesn't slip out from the holes. Now we're going to mount it on the clips of our vise so we can easily solder it. Heat transfer will be improved if you melt a little solder on the end of your iron. Touch the tip of the iron to both the pad and the wire and count to 3. 1001, 1002, 1003. Push the solder in the other side. Then solder out and iron up. We'll do the other wire with the same process. Touch the iron to both the pad and the wire and count to 3. 1001, 1002, 1003. Now we'll trim the wires just above the solder joint. A good solder joint is shiny and in the shape of a Hershey's Kiss.